Hello and welcome to CSCI 40. My name is Lawton Nichols, and you can't see me at all right now, so let me start up my webcam so you can see my face at least once, just in case you decide to never come to office hours. Sure. Hello, this is me, with a very bad green screen. Nice to meet all of you, and welcome. Yeah. Leave that. Quit that. Unplug that. Alright, we're back. So today is going to be a little bit of just random logistical things, like I'll talk about myself, we'll talk about the syllabus, and then we'll actually get into programming, which will be really fun. So a little bit about me. My name is Lawton Nichols. Hello. I use he and him pronouns, and I would like it, if you feel like it, if you would call me by my first name. I know that might sound weird to call an instructor like that, but I want to earn your respect. I don't want to just be given it. Otherwise, I will respond to things like Mr. Nichols, Dr. Nichols, Professor, or whatever else you want to call me. But if you feel like it, please ditch those for Lawton. Alright. With that, I went to Fresno State for my undergrad. I majored in computer science, everywhere that I'm about to talk about. So if you're thinking about transferring there, I know a bit about the program. And yeah, I just got done with grad school at UC Santa Barbara, so this is my first semester here. And therefore, I'm sorry, for 6 years I've been dealing with quarters. Sorry if I accidentally say that instead of semester. Other than teaching, I like to do some human things, and these are my beautiful moss balls, and I hope, once I get my first paycheck here, that I will be able to afford a cat, and I'm very excited for that. So thank you in advance for putting up with me. This is going to be a really weird semester, and especially because this is my first time here, I'm sure, and also especially because it's online, I'm sure there's going to be stuff that I have not planned for that will happen, and we're just going to have to deal with it as it comes up. So thank you in advance. We will get through this together. Alright, some logistics. As you might have noticed, everything is asynchronous, so I'm going to record everything for you, every lecture, every lab intro video, if that is necessary. And here's the schedule that I will try to keep every week, so you can expect the first lecture video up by Tuesday at noon, and then the second one up by Thursday. We'll pretend this is like a 2-lecture-a-week class, and then you'll also have a lab section, where you're mostly going to be working on an assignment that I give you, by yourself. So I'll have the introduction for that lab up by Friday at noon. And because there's no class time, I'll give you a window, like a 24-hour window to take your exams. And it'll be like a real class, though, once you press the start button. You'll have 24 hours to pick your time you want to take it, but once you press start, you'll have a normal class amount of time to take your midterm, for example. Okay, so that's the idea with that. Hopefully that makes sense and seems fair. As far as expectation goes, let's get this out of the way. So this class is a bit hard, and I am sorry. There's just a long list of things I need to get across to you, and programming is definitely a new way of thinking. So in order to get you up to speed, there's going to be a decent amount of work, so prepare yourselves for that. And also, this may be a good thing or it may be a bad thing, but you can't really memorize a whole lot in this class and expect to do well. It's going to be more about using the tools that I give you, the language that I'm teaching you to speak, to solve problems. Okay? That's the idea. And so you may very, very well, depending on your skill level, get close to the dreaded 4-unit class equals double the unit hours outside of class some weeks. So just prepare for that and set time aside. This class is going to take some time. But with that in mind, I'm not here to scare you. I love this information, this field, and hopefully I can rub some of that off on you. And I'll be here to help you as much as I can. We'll talk about my office hours, and I will have plenty of those. So please come yell at me if anything ever doesn't make sense. I'm here for you. I'm happy to help. That's what I'm employed to do, and I love it. Okay, so let's talk about the syllabus really quick, and then we'll go to it on Canvas. So you can expect to have homework and 2 different kinds of programming assignments each week. So your homework and your Xylabs are going to be out of your textbook, and then you'll also have some labs separate from these Xylabs that you'll work on this virtual machine thing that I hope you got installed. Okay? There will be 2 midterms. One, the first, like a third of the way into the class. The second, 2/3 of the way into the class. And you'll have extra credit, and we'll talk about the other things once we go to the syllabus. All right. So here we are on the home page, and click syllabus. Go to that. I'll just open it up in Firefox itself. And you can read most of this. I won't bore you with it, but the thing that you care about, I think, is this grading scale. So 10% of your grade is going to come from the Xybooks homeworks, not including the Xylabs, and 15% of your grade will be from programming assignments on the Xybooks website called Xylabs, okay? And then 20% of your grade would be from labs on the virtual machine. So those will be just labs. Okay, sorry for the terminology, but that will hopefully make sense after you've done a couple. And then instead of attendance, because obviously you're not here with me right now, this is going to be how I'm going to keep attendance. I'm going to have these weekly check-in surveys on Canvas that I will ask you to complete on the modules page. So here will be your first one. Yours might look a bit different right now. I'm in the teacher mode, of course. So please make sure to complete that first check-in survey this week to get credit for attendance, and make sure to keep up on those. This first week, I am required to, if you do not complete the check-in survey, to drop you from the class. So just keep that in mind and do that on time. That will be attendance. And then we'll have midterms, 2 midterms for 15% of your grade, and then a final for 20%. Okay? Hopefully that seems reasonable and makes sense. And I know that this semester is going to be difficult for a lot of us, so I will drop your lowest 3 homeworks, your lowest 3 Xylabs, and your lowest 3 labs. Okay, so just to give you some breathing room just in case things get weird, or extra weird, I guess. And yeah, standard grade breakdown. I'll give you some extra credit in case you need it. And yeah, with that, the final exam. So I actually just yesterday learned the rules, so this will have to change. The idea is I can give a 24-hour window during finals week, and then you will take the exam during that time. Okay, so that is going to be the plan, but I have yet to pick a day. That is a lot of, I don't know, that's a lot of stress. So I don't want to pick a day right now because I'm not sure what day is the best day. So we'll figure that out later, okay, and I'll let you know. And I'll be definitely lenient if you cannot make that day for some odd reason. But hopefully the 24-hour window will be good enough. So yeah, TBD for the final exam. And yeah, hopefully you've watched the video and got that Linux virtual machine up and running. If not, please come to office hours and yell at me and I'll get it working for you. It's a computer inside of your computer. It's so cool. It has a cat background. That was actually the default. I didn't even have to pick it. It's wonderful. But yeah, please watch the video on Canvas. This is it. This is the terminal that you will live in. And yeah, little file browser, web browser. It'll be fun. And another thing that I want to mention is if you are in need of a laptop or a better internet connection with they give out these little MiFi routers and also laptops. So please see the resources page on Canvas. If you are in need of any of those things, the college can help. Okay? And then, yeah, the class server is where you will be submitting your things, but you shouldn't have to touch it. This is just for your information. So you're going to turn stuff in by copying them to our class server, but that will just all be done through terminal commands on the virtual machine. So you shouldn't have to really worry too much about this other than changing your password. So just remember to do that. Okay. Xybooks, that is going to be our textbook. And it is virtual, it is interactive, so you can't buy it used or anything. And I'm going to assign you homework and Xylabs out of it. So you have to buy that. And it's really cool, the interactivity, so I think it's worth it because of it. So let's go here. Yours will not be inverted. This is what it looks like. Here are your assignments on the right here. And you can see which ones you need to do at which times. So all of those homeworks and Xylabs will be assigned out of here and not on Canvas. So just make sure to keep checking this site. All right, and this is what a little section of a chapter looks like. Teaches you some stuff, has little animations, and has some checkpoints to make sure that you're understanding things. So I think that's really nice and helpful, and I hope that you also enjoy it. So yeah, if anything, I'm going to extend the deadlines of things if I have to, so it will definitely not hurt you to read ahead, and we already looked at it. Okay, moving on to Piazza, just blazing through this stuff. So on the left-hand side, you see this thing called Piazza, and also on the home page, I've linked to it. So Piazza is where you will go to ask questions or contact me, because my email is disgusting. I might not get back to you because I might not see your email. So please use Piazza because I will get push notifications for this. So what you can do is make a new post. Usually you'll be asking a question, and you can either send it to the whole class, which means your peers can help you find the answer, or you can send it to just me like a private question, which would be the equivalent of a private email to me. Okay? So you have both of those options, and I hope you choose to use the public question option as much as possible, because that means your peers might get back to you faster than I do. But I'll try to get back to you in like 24 to 48 hours, depending on if it's a weekday or a weekend. But please use your judgment when asking a public question. So don't like share all your code, which is an answer to an assignment or like the midterm. Just use your judgment there. And yeah, but normally most of the time I'm sure you'll be asking public questions just for like clarification on things. Yeah, and just to lower the barrier for asking those kinds of public questions, you're allowed to post anonymously on Piazza to your peers. Okay? So consider it. And yeah, please, I strongly encourage you to use Piazza instead of email, because my email is disgusting. And then finally, please come to office hours. They will be on Zoom. You can make an appointment if you need to, but I have set aside 6 hours a week, and hopefully these won't change. I might get like sucked into meetings and these might have to change, but this is what I have so far, nicely aligned with your due dates. So you'll click this link up here to come to my Zoom session and talk to me during these times. Okay, so just keep checking this page just in case they do change. But yeah, I am happy to help you during these times. Please, please, please come to office hours. I yearn for human interaction. It's so weird to be talking to myself right now. Okay, so now we're ready. We are ready to learn some programming. All right, so I don't want you to be overwhelmed, but I will be throwing a lot of stuff at you right now. These first few lectures, just to get you up to speed, you have to know quite a few things. So you can always keep coming back, and you can always yell at me in office hours. And I encourage you to like rewatch these things, try out this code yourself. I'll be giving it to you. Yeah, I'll be giving you these slides with my annotations as well. Yeah, you're gonna get everything. So these are my goals for you. Feel free to read them. They're more for me than for you. And let's get on into computers and programming. So a program, it's really just a recipe. There's also this word called algorithm, which is specifically a sequence of steps that you take to solve a problem. So it's like a little mini recipe, and a program is like a bunch of little algorithms all fit together that solve individual smaller problems, and you build up your solution with all your little tiny algorithms inside of your program, and then that makes the final answer. Okay, so my question for you is, how do you make a peanut butter and jelly sandwich? I know this is really difficult. Here's one for reference, if you need to know. And, well, I'm going to pretend now that I'm a computer. So please give me the algorithm for creating a peanut butter and jelly sandwich. All right? Pause the video if you have to. And now that you're back, welcome back. I know you thought so hard. If I could read your mind, perhaps you said something like this. You got your bread. Here's my bag of bread that I'm going to draw. Dun dun dun, dun dun dun. It's got some slices of bread inside, and I don't know, then you have your peanut butter. That could be drawn better, but that's okay. How about that? Peanut butter. Then you have your jelly jar. And maybe your algorithm is, all right, you take the peanut butter, you take the jelly, you take the bread, you put them together, and voila, you have peanut butter and jelly. So, hearing that, as a computer, this is what I would do. All right, I am your resident computer. You're like, all right, take the bread, I got you. This is a horrible looking bread, but this is the bag of bread. And all right, then you take the peanut butter, sure. put it on the bread. I think you know where I'm going with this. And then you put the jelly on top of the peanut butter. Yeah, so then you got your bread, and then you put peanut butter on that, and then you put jelly on that. And so I have made for you peanut butter and jelly, just as you said to do. Ta-da! It was so easy. But yeah, this wasn't what you wanted, was it? So, now you see the difference between humans, who know what you're talking about, and computers, which just follow instructions blindly. So you have to learn to do this kind of thing called computational thinking. You have to think like a computer, which means you're going to have to give little tiny steps. You're going to have to think at a more finer grain level, all right? Because the computer can only perform certain kinds of steps, of operations, we say. And so you're going to have to break problems down into those bite-sized pieces. And in addition to that, there's always there's a notion of sequentiality. All right, so in a program, you're going to say first do this, then do that, then do this thing in that order. So that's kind of like the 3 pillars of computational thinking that I'll be teaching you. So the real program that you should have given to the computer, or me, was take some bread out of the bag, open the peanut butter jar, use a knife to put some peanut butter on one of the slices, use a knife to put some jelly on the other slice. So now you see where I'm going with this. Put the bread slices together. All right, that's the idea. So now, let's talk about just a few terms that you'll be seeing quite a bit. So an algorithm, it's just like a recipe. We've talked about that. It's a sequence of steps to do something. And then testing is going to come up later. You want to trust that you did the right thing, that your program is correct. One way to do that is through tests. And, for example, eating the finished sandwich is a test, is running a test. Okay? And there's also, when I give you a problem, there are a few assumptions that may be implicit that you'll have to discover. So if you want like a quick example of an assumption that you'll probably have to make, if I go out, it's my birthday, I buy some birthday candles, and I want to light it, well, the manufacturer of those candles is assuming that I will not be underwater when I try to light it up. So there are some assumptions that you need to make or infer about the programs and the inputs on which they will be running. And that's all really vague, and we'll get to plenty of examples with that. And then finally, computational thinking. Thinking sequentially, clearly, and at the right level of abstraction. So think in terms of what the computer can do, and make sure that it's doing the right thing in order. Okay, so that's the goal of this class, really. And that brings us to the parts of the computer. Okay, just in case you haven't seen these before, we're going to get ourselves all on the same page. And they all work together, these parts. Okay, so think of an input device. What's your favorite input device that you can think of? It gives data into the computer. Input. Well, one thing is the keyboard. I think that is probably the most logical one. You got a mouse as well, giving directional input. Touch screen. You tap that, and it gives it tells the computer or your tablet or your phone exactly where you touched, and it allows a menu to pop up, for example. Then we have output devices, the opposite. So how do you get information out of the computer? Well, display / screen is one. And then another that you might think of is printers. So it's going to just print out some text for you. Okay? That's the idea. And then the bulk of the work is done by these two, so the processor and the main memory. So processor is also called CPU, which stands for Central Processing Unit. And this is like the brain. It's what does the thinking. This executes or runs your program. Okay, you might have never heard the word execute before. It's not like you're killing something. It's just you're running the program. You're running your steps in order, and it's doing what you asked it to do. Okay. Then your main memory is kind of still part of the brain, I would say. It stores information. about running programs. So every time you want to run a program, it needs to get copied into the main memory. Okay, that is the idea. And secondary memory, well, if it's not main memory, if it's not RAM, this is also sometimes called RAM, random access memory. Secondary memory is like a bit slower. It holds more things. It's where your files are stored. It's where your programs are stored when they're not being run just yet, so that you can copy them into main memory. So this is like your hard drive, or like your USB flash drive. Hold lots of information, slow to access. And main memory, or RAM, is really fast to access. And so that's why we want to copy everything there before it gets run, and so that the CPU can access it very quickly. That's the idea. Okay, and so these all work together. It's like you write a program, it's going to be loaded off of your hard drive, your secondary memory, into your main memory, and then it starts running on the processor, and maybe it asks for you for some type of input, like what is your favorite color? You give that through the keyboard, and then you get some output through, maybe it makes a picture for you with that color on the screen, an output device. Okay, that's the main idea. All those important parts, just in case you haven't seen them before. And that brings us to C++. So this is the name of the programming language that we will use in this class. And it was invented back in 1985 by this nice Danish man named Bjarne. Just as a quick edit, I learned how to pronounce his name properly. It's Bjarne Stroustrup, and I accidentally put a T here, so sorry, Bjarne. It's all spelled correctly now. And so C++ is a high-level language, and that means that it looks more like English than the ones and zeros, which is, we'll call machine code. Okay, that's essentially, deep down, you need to make ones and zeros, binary information, machine code that runs on the processor. But when we write programs in C++, it'll look a whole lot more like English. Okay? And it's what's known as a compiled language. C++ is compiled. So another program that is called a compiler has to convert our English-looking words to those ones and zeros that the processor can actually use and run. Okay? So right now, I'm going to write a very simple program that does absolutely nothing. Okay, so let me show you the simplest complete program. And in order to do that, we're going to have to work on the terminal quite a bit. So here are some things that I'm going to teach you, but this is all a whole lot of information, so let me section it off. Boop. How's that? And for some reason, it just never lets me resize it, and we'll figure that out together. So once you plop yourself into the terminal, this is what you get. When you open it up for the very first time, it'll plop you into what's known as your home folder. Maybe I'll make it small. Okay? So this tilde means your home folder. Alright? You can always get back to it. If you double click it on the desktop, this is what it's look like. This is what it looks like, and these are its files. So your home folder is that. And it's really a place. It's called, it's really a folder on your computer, and you can see what's inside of it. Directory. So every time you're in the terminal and you're looking at something, you're always inside of a directory. So I'm currently inside of my home folder, and I can do work inside of that. So I can see what's there, I'm so sorry, by typing ls, which stands for list. And so it's going to list all of the files and directories that are inside of this current working directory that I'm inside. So it's as if I opened up my home folder in the file browser, and I can see all the things that are there and double click on them if I have to. Okay, so that is my home folder, and those are its files. And the home folder, the tilde is just a shortcut. So really, if you say pwd, it stands for print working directory, and it shows you the exact file path, folder path, I guess, where you are in the file system at the moment. So really, inside of the root directory is a home folder, and then inside of that is a Lawton Nichols folder, and that just so happens to be my home folder. Okay, that's my tilde. Yours will be CSCI. Okay, that's print working directory. Now, we want to move around. We want to change our working directory so that we can get into the CSCI 40 folder that I've made. So if you want to change the directory that you're currently in, you'll say cd. So I want to get into my code from class folder, and that just so happens to be inside of this Windows desktop folder that I made for myself. So I'm going to, this one right here, if you look at it on the terminal. So I'm going to change directories to go inside of that, and you can type tab to have it autocomplete. So cd Windows desktop, hit enter, and then now I'm plopped inside of my Windows desktop folder. It's as if I had double clicked on it. Okay, so I can see what's there, see all the same things. Hit pwd to see where I am now. So yes, I went inside of my Lawton Nichols folder, inside of the Windows desktop folder, inside of that. Okay, pwd. And just in case you're ever lost, you can say cd tilde to get straight to your home folder. cd tilde goes straight to the home folder, or if I'm in my Windows desktop folder and I want to go out, this will work everywhere. If I just want to go to the previous folder that I was in, the one that is my parent, so I want to go out one to the Lawton Nichols folder, which is my home folder, you can say cd dot dot. That stands for your parent directory. So this will also get me out one to Lawton Nichols. And you can see cd dot dot again to get to the /home folder, which would contain everybody's user account, but there's only one on this machine, and so on. Cd dot dot to the root directory of my file system. You can't go out any more than that. Here's what it's there, and now back to my home folder, and now inside of my Windows desktop folder again. Okay. So if you ever get lost, you can always go to your home folder. You can always go out with cd dot dot. Now, I'm going to make you a file inside of my lecture 1 folder. So Windows desktop, inside of that I want to go to my code from class folder. You can also end it with that /, not a problem. So that's like I double clicked on this now. So my current working directory is this. What's there? These 2 folders. These are actually hidden files that you can see with ls-a if you felt like it, but we won't get into that right now. Let's go inside of my CSCI 40 folder. And then inside of that, I've made a lecture 1 folder, so you can see it there. Let's go inside of that. And right now I have one file that I will show you later. Alright, we're done with the file browser. We are ready to work just in the terminal. Okay, so I'm going to make a new file called donothing.cpp. It's going to be the simplest possible program. So I'll say nano. That's the name of the editor. It's a program that's going to make a file for me if it didn't already exist. Otherwise it would start editing that existing file. Nano donothing.cpp. And I'll hit enter to bring up this program. And so now I can start typing and it'll edit this file. .cpp is the customary extension for a C++ file that has implementations. Okay, so let me make you the simplest possible program. Int main, return 0 in between braces, just like that. So after you're done editing your program, you can move around with the arrows, of course. Here are your options at the bottom for how to use this program. The little caret symbol means control. So if I type Control X, that will start the exit process and get me back to the terminal. It'll also save the file. It'll ask me, do I want to save? I'll type Y for yes, and then it'll tell me, or it'll ask me, what's the name of the file that you want to save right now? Do you want to save it, what you just did, as something new? And I'll say no. You've typed the name of the file already, this existing file. I just want to save this one that you've already made for me. Okay, so I want to keep the same file name. Hit enter, and now it has saved that file. Okay, super simple, not too bad. Now, okay. There's also another text editor called Vim that I will be using for the rest of this class, but it's a bit harder to use. And so I encourage you to start out with Nano and then get up to speed with Vim. So, I think we're ready to get rid of all this now. In order to compile this program, so that it will run on our computer, we just need to say G++, that's the name of the compiler. It stands for, if you're wondering, GNU C++ compiler. That's the name of it. And then we give it the C++ 2017 standard. That's the newest and coolest thing. And then we give it the name of the program that we want to compile into machine code so that we can run it. So again, we'll say G++, standard equals C++17. Don't worry, you will get used to this. You're going to be forced to do it so many times. Then the name of your program, hit enter. And now it's compiled, and that means it made a new file, a new program that holds machine code. You can't edit this. It's called a.out. You try to open this in Nano, it looks like garbage because it's machine code now. Okay, so we'll say // in order to run the program. /a.out. Okay, what that means is it stands for in the current directory. So ... is your parent directory. Dot just so happens to be your current directory. So when you say // it means run this thing in the current directory that exists there. So I'll say // a.out, hit enter, and voila, we just ran our program that did nothing. Yay! So that's that. What just happened is your question. So let me go back into that do nothing.cpp file and start marking it up. So this is a comment. If you start a line with 2 slashes, it's called a comment. It's a single line comment. It's only for the program. The compiler doesn't care about this, about comments, let's say. They're not actual code, they're just notes for you as the programmer. That's a single line comment. You can also make a multi-line comment with pairs of /* and then */. So put multi-line comments, and so then you're just done with the comment when you type this */. Okay, that's the idea for comments. And so now let me comment up this program. So main is called a function. So it's a function that gets run right when the program starts, and all this terminology you will get used to. We say it returns an integer. And this 0 is called an exit code. So it gives back 0 to the terminal. Zero stands for success. Any other number than 0 means failure. So if you returned 1, it would tell the terminal that this program didn't end properly. Something was wrong. Okay? So that is why our program does nothing. It starts, it runs this main function, and all it does is immediately stop the program, because returning from main stops the program. Okay? And yeah, all of main happens between these braces. The body of the function, we say, happens between the braces. Okay? So hopefully those help make this program make sense, and I will give you tons of examples to make it make sense even more. And so these comments do absolutely nothing. If I recompile, and you can type the up arrow to get at your previous commands to the terminal, if I recompile and rerun, no difference, because those were just words for us. Okay? Now why, you might be wondering, are we teaching you C++? Well, there's a few reasons. It's on the lower side of high-level languages, if that makes any sense at all. So it's kind of like English. I've said the word return, I said the word main, but it's also very close to the computer. It's very close to the hardware, so you can touch the memory very easily, and that's important when you're learning how to program, to understand how the memory is arranged and allocated, deallocated, how your program executes. So we get to touch the bare metal almost with C++. It's also super fast. Perhaps you've heard of another language called Python. That's the other standard introductory programming language, and I teach that in CSCI 1 if you're interested. Python is really slow. And so C++ is super fast, and because of that, all the cool kids are using it. Like all of Google, they're using C++ all over the place, including The entirety of Chrome was written in C++. So is Firefox. All of Adobe is writing their programs in C++ because it's fast and it's usable. And then any game that you probably play is most likely, for the most part, a lot of them at least, are written in C++ because, again, you can do things quickly. All right. Oops. That's the idea. That's a little bit of motivation now. So, yeah, I talked about this thing called a compiler, and a compiler is what takes a single program and it translates it down to machine code, or also called object code. Now, this is kind of the pipeline for your compiler, and linker as well. So there's also this other thing called a linker, and G++ does both. It both compiles and links at the same time for most of the programs that you're going to use to write in this class. But there is a difference. So I might abuse notation and say G++ compiled your program, now you can go and run it. But really, there's a linker step that is important. Okay? And so the idea is we took our program called donothing.cpp. It's up here, I guess. And we gave it to G++, the compiler. And it spat out ones and zeros, the object code or machine code for our program. And then G++ went and linked it with any libraries that we needed to use. And it just so happened that we didn't need any, but we'll get to some called cout and cin that are library implementations of output and input. So that's super helpful, and we'll use those. So a library is just pre-implemented code that makes your life so much easier because you didn't have to make it yourself. Like, how did you dealing with the operating system to output a character of text to your screen? Cout's going to deal with that for you. You don't have to. So in case your program uses libraries, those will be brought in at this linking stage, and then finally you have your final program that can be run, a.out. That's the pipeline. Just keep that in the back of your mind, and now let's do a bit more. Let's write some more programs and learn some more C++. So the first program that is customary that you write, it's tradition, to write a program called Hello World. And so what it does is it just prints out to the screen the words hello, world, ! It's as if like you're giving birth to this brand new program and this brand new language that you learned, and this is like the simplest thing that is not just blank output. All right? So we're going to tell our program to say back to us, hello world. All right? And I've talked about comments already. Those are the // and */ /**/*. Alright. So let me make a file now called hello.cpp. And before that, just in case you want to learn Vim instead of Nano, there's this terminal command called vim tutor that you can just run by itself. You can move around with the arrows, and this will teach you how to use Vim, this cool thing that I'm using. Okay? Just in case you want to get away from Nano, but Nano will work for now. Vim hello.cpp. Alright? So, well, okay, let's make our main function. Let's do everything we know already. Main function that returns 0, the simplest possible thing that is correct. Now, I want to say back to the computer, hello world. So I'll put that within quotes. And I will give it to this function, to this library code called cout. Alright? That's what I'll do. But it's not anybody's cout, it's the standard library's cout. Okay? So this will print hello world to the screen. And cout, standard cout, prints the text you give it to the screen. Okay? Now, we can't run it just yet because I told you that this was a library function, and we need to include the library. Okay? So in order to do that, we need to include IOStream, which will give us access to cout. Alright, we save the file now. And I'm going to make a new terminal just so I can show you the program and its output at once. Alright, so let me just quickly go to this folder. When is this? Code from class, CSCI 40, lecture 1. There we go. So I'll say G++ to compile it, remember. Standard equals C++ 17, hello.cpp. Hit enter, it compiled it. Okay, so now it made a new file. Well, it updated the old one. We had a.out before, and we recompiled this program, and so it replaced a.out. And you can see that if you type ls-l to show you more information about the files. So it'll tell me that a.out just got changed at this time, and hey, it just used to be that time. All right, so I can run that again with /a.out, and drum roll please. Boop. Hello world. Beautiful. Actually, sorry, on yours, if you run this on your terminal, it'll look like this. Gotta make this longer. What a horrible prompt. /a.out. It'll say hello world and then give you right back your prompt. Whee! Do it again. There we go. Okay. That's what it'll do. And so we kind of want this to be on its own little line. So we can use a shortcut for press enter please. And that is called \n. Alright? So \n presses enter. There are a few others. So \n, enter. It's called new line. There's another called \t for press the tab key. So it'll tab over when you're printing things out. And there are others. Plenty more. Backslash actually includes that / character because it's being specialized for these other things. So that's how you get around that. These are called escape codes, escape characters. But don't worry about that. I'm going to show you exactly how to use them. Alright, so if I want to type enter now in my program, I'll type \n. That will type the enter key for me and make things on a new line. So I'll recompile. G++, standard equals C++ 17, hello.cpp, and it'll make that a.out again. It'll recompile it, replace the program, we run it, and now it pressed enter. It's all on its own little line. It's beautiful. Okay? So there is shorthand for this \n though, and it is called endl. So let me copy this. So we can do that. We can say endl. But whose endl is it? It's the standard libraries, right? That's the idea. Standard endl is equivalent for your purposes to \n. Right? It's slightly different, but it does the same thing. And here's a case where you can give multiple things to cout. You can give one thing, you can give another thing, and have it print to the screen. And let's talk about this. So cout takes information, and you can think of cout as like your screen. And you're giving it information. You're shoving information into it with these little arrows. So think of the direction of data as the way the arrows are pointing. So I'll actually put it up here at the start. So think of those things, those two less than signs, as arrows that point in the direction of data, okay, of data transfer. You're giving data to cout, okay? Hopefully that makes sense. You're shoving words into the terminal's output screen, yeah? So, just to prove to you that these do the exact same thing, I'll recompile, rerun, 2 lines do the same thing, and now you see how your program's executing line after line after line. And this brings us to another important piece of C++. I'll just get to everything in due time. A complete statement in C++ ends with a semicolon. It's like a complete thought. It's a period. It's the equivalent of a period in English text. That's how you tell the compiler, hey, I'm done with this, please do this whole thing. Okay? So this one line does one thing. This next line does another thing. This third line does another thing. Okay? And they're all separated by semicolons. And ended by semicolons. Okay? That's the idea. And so now, we've done all these things. It's so nice. We're using the standard library all over the place. Wouldn't it be nice if we could just get rid of those standard colons? And there is a way. You can say at the very top of your program, using namespace standard. So this allows us to not have to use those colons. Yeah. So now I can replace these. So, delete. I'll keep it there. Delete, delete, and I'll keep that one there. Okay. So these do the same thing now, and we just skip saying standard : all the time by saying using namespace standard. So at the beginning of your programming career, these will be the first two lines you always type in your program. Okay, so recompile, rerun. No difference. Oops. Recompile, rerun, no difference. Same output. Okay. Let's see. Everything between quotes is called a string. Okay, it's just a bunch of characters, and we talked about \n. It's an escape character. It gets replaced with enter. If you ever want to type the actual \/ character, you have to type 2 of them. All right. So, hello world is called a string. Think of it as like a string of characters on like a friendship bracelet or something. That is called a string. Yay. So, and then the very last thing before we go to simple math is white space does not matter in your program. If you're coming from Python and you programmed before, it's not a requirement. You can put, you don't have to do like, you can make your programs really ugly in C++. The compiler is only looking for those semicolons, so you can do this, put these on different lines, put this on another line, put the semicolon on this line, but way out there. I can actually put all of these lines on the same line. You can just start typing after that. So that will still work, but just use your judgment. Try to make it pretty. And there's actually a program that I'm using whenever I save this file called Clang Format that makes it pretty for me. Okay, and now we are ready. We are ready to do a little bit of simple math to get the area of a circle. All right. So let's close this program that we're working on, and let's open a new one called area. Okay. So we're going to do the same thing. Include IOStream, and this gives us for cout. We're going to use namespace standard, so we don't have to say standard : cout. We can just say cout. And then we'll make our main function, because that's the first thing that happens when our program gets run. And the main function exists between braces. And then the last thing that usually happens is the program indicates that it's done successfully with a return statement. Okay, so now we're going to get the area of a circle. And so we'll just cout a value and then a new line. And so let's pretend that our circle had radius, I don't know, 6.78. So all we have to do is type pi 6.78 squared. So 3.14 times that. A star means times. And then you might think that ℝ2 means squared, but that is not the case in C++, so watch out for that. Caret is not the power operator in C++. It does something else. We might get to that at the very end. Oops. Is not the power operator in C++. So, instead of that, to square a number, let's just multiply it by itself for now. So that's pi r squared, and we'll print that number out, okay? So C++ can do this kind of arithmetic for you, calculate the answer, and then show the final solution as just a number. Okay, so I'm going to compile and run this now. G++, standard equals C++ 17. This is called area.cpp. And you can see the name of everything I'm working on at the very bottom here, in a few places at least. And so that'll make a.out, and I'll say /a.out. And this was apparently the area. Good job, C++. Thank you for that. All right, so we just made a few programs, and we should feel really good about ourselves. We are so cool. We're so cool right now. Let me check the time. Oh, we're doing great. Okay, so with that, that brings us to variables. So we don't just have to calculate things and print things, we can save stuff for later. That's what variables give you, and we can change them around. We'll talk about these in depth in the next lecture. But variables have an associated type, and then we'll talk about how to input into them. So a variable is just a box in memory where you can save something for later. So let me make a new file called vars. vars.cpp. And remember, I'm going to give you all of this code. I'm going to cheat and include so many things. I'm just going to copy and paste. Hey, don't mind me. All right. So let's talk about variables real quick. Int x equals 42. Okay. So what this is, it's a variable definition and declaration. This makes a place in memory, in main's memory, called x that has the value 42. Okay, that's what that means. And so now we can save x for later and just say x instead of 42. All right, so let's print that out. Cout x in any line. And you can give so many things to C++, as long as you put them between those arrows. You can give cout whatever you want. So now let's compile and run this. It's called vars.cpp. And I'm actually tired of it being called a.out all the time. So if you ever want to compile something to a file name other than a.out, here's what you can do. You say G++ standard equals C++ 17, the name of the file again, -o, and then the name you want it to be called. So this will make the compiled file, machine code file, thing that can be executed, all right, instead of a.out, which is beautiful, right? So now we can say -o vars, please, and you can make this whatever you want, but I'll call it something normal. And so now, instead of replacing a.out again, it made a file called vars that we can then go and run. Okay, that's the name of our program now. And it prints 42 for us because we said x. That was what it was. Okay, there are other kinds of types. Ints mean whole number, so it can only store 42, not 42.5. So in terms of pizzas, an int stores just as many pizzas as you ordered in your life, for example. And then there's another thing called a double that stores decimal numbers. And those are like fractions of pizzas that you have eaten. So double D equals 3.14. That's definitely a low ball number for the number of pizzas that I have eaten in my life. Okay, and that'll print that out. You have single characters. Let's go to, comment this a little bit. Doubles store decimal numbers, so numbers with decimal places. It's not required. You can store 3.0, but it's made to store them. And all right, moving on. Char stores a single character, so like your middle initial, char c equals h, that's my middle initial. And I'll put just a single character at a time. Char is for characters, and single characters has to go between single quotes. Okay? And then string is when you want to put a bunch of characters together, and we've used that already for hello world. So we can save a string for later by putting it in a string variable. String s equals pepperoni. And then we can output it. Okay? These are all different kinds of types that you can store things in. And it'll output them all. Let's put like that at the top. There. So that's printing them all out. Beautiful. Okay, so those are what variables are. And it's the type that really matters here. So int is like, think of int like a cloud, and it can hold certain kinds of things like 42, -2, 3, 0. That's hard to differentiate int, so maybe I'll make int in the coolest pen ever. Int. And then double's similar. And then other things like char and string. But I'm sure you'll get the idea at that point. So double is like 3.14. You can still store 0. You can store really big numbers like 3 e to the 70, and the e stands for times 10 to the, so it's 3 times 10 to the 70. Characters, single characters like A, B, $, things like that. Okay, I think you get the idea. And then finally, cin is the opposite of cout. It gets input from the user and it writes it into a variable. Okay, so let's make a new variable, int y, and we can ask the user to enter something. So cout, please enter an integer, and then press enter. And so we'll ask the user for that. So we're going to print something out and not make a new line so that they type on the same line. And we'll say cin into y, and look at the direction of the arrows. Information is flowing into y. And cin is like your keyboard, into y. Okay, so that's that. And yeah, at this point, because everything executes sequentially, now y has whatever value the user gave it. And we can print that out. We can say, you typed, and then a space, and then that variable, and then a new line. Okay, that's the idea. So we can go and run this. And now it's waiting for me to enter an integer. I'll give 55, hit enter, and I'll say you type 55. And now our program changes depending on this input. If I rerun it, I can say 47. And it says you type 47. So that's input from cin. Okay? And now with that, we're at the end of the lecture, and so I just want to give you a cool example to end the day on. And then we'll also do some exercises. You know what? I'm going to save that for the very end. Dun, dun, dun. So let's do some exercises really quick. So first of all, what does a compiler do? Take a second to think about this. Does it run your program, store your program, translate it, make you a peanut butter and jelly sandwich? Well, I think if you go back to the start, you will see that the answer is indeed C. All right, a compiler takes your high-level program, like English, translates it down to machine code for you to be able to run. And now what is the terminal command to compile something and to run it, okay? So it depends if you want it to be called a.out or not, but I think you know the drill at this point. You say g++, standard equals C++ 17 x.cpp, and then to run it, if you're in the same directory, you'll say /a.out. You can alternatively give the -o. And at that point you can say /blah instead to run that. Okay? And then on your own, I want you to try this. These exercises are of course optional, but this might help. So write a program to convert a number to a capital character. So convert 0 to A, get it from the user, make it an A. Get a 1 from the user, make it a B. And here are some hints that you can look at on your own time. So now, I want to take you to this super fun demo where I made this program called karaoke.cpp, and it's going to play back to us a song in the order that it exists, in the order that the lyrics should be displayed to you. And so I'll put it maybe over on this side. And it plays a song that I think you all know, which is Frozen's Let It Go. Okay? And so I want you to look at this program not too carefully. There's this function that I'm not going to ask you to ever implement. I had to look it up myself, which stops the program for a couple seconds. So this is going to print something, wait for a second, print something, wait for another second, and then print other things. All right? So it's going to start typing the text, and then waiting in between when it should display the text the next time. That's what a karaoke machine does. It's going to sing this song to us textually. Okay? So I'll get this ready over here, and we'll compile it. G++, standard equals C++17 karaoke.cpp-o karaoke. And so now it's ready to go. And I just need to start this song at the same time. So I encourage you to look this up and watch it at the same time as I play it, because I'm not allowed to let you hear it, otherwise they'll take my channel away. So this is Let It Go, and we're going to put it over here, and then we're going to play it, and it should sing it to us as it plays. Alright? But the trick is I have to start it at the exact time that the program is asking me, because all these times are completely down to the second accurate. So I'm going to run this program. It's going to tell me it's going to print some stuff out. Okay? Are you ready? Maybe this can go over here for a second. Okay, are you ready? I'm going to hit enter. 3, 2, 1, now. And what it's going to do is it waits in between things. So you see pause, pause, pause. It's going to print things, then wait some more for those second values. And you have enough information. You know how to do this now. Just run pause, run cout. You can make this program. And look at it singing to us. I hope you're playing it right now yourself. So it's just printing, waiting, printing, waiting. That's all you need to make this program, and I think it's pretty cool. I hope you get this compiled on your own and running. It's more fun to hear it. So I'm going to leave this chorus for you. Get this compiled, get this running. That'll be your reward. Okay? So with that, thank you for getting through this first lecture with me, and I will see you in the next one.